Hi, and welcome to an MCSS session on climate and history. I've got a starter PowerPoint up here, and it will open up a number of other PowerPoints that explain how to use some handouts that we would give if we were in a live room here. What I will do is show the PowerPoints as if you had the handouts. They were available up on the website. But after that, I will just go through each of the handouts in order and explain some of the ways that teachers have chosen to use them in the classroom. So with that as background, let's take a quick look at climate proxies, how we know what it was like a long time ago. In other words, we can talk about a climate map in a few minutes, but let's think first about how we know what we know. After all, no one was alive or able to measure temperature back at the close of the Ice Age when humans were starting to migrate around the world. All we have is indirect evidence that's called proxies. And here are some of the useful climate proxies: diatoms, dinocyst coral reefs, lake pollen, and so on. I have personally done about 5 3/4 of these. In other words, I've been out on a frozen lake pulling a sediment core up from 140 feet down, and this is what a sediment core looks like. We can look at the pollen in different layers, and that'll give us a clue about what was growing around the lake at different times in the past. The graph goes from relatively old to fairly recent, and we know that there were a lot of grasses around here, and that suggests that that was a particularly dry time. Then when there were a lot of rainy pine trees, a lot of pine pollen, it might have been a rainier time. Or you just had one big pine tree right next to the lake. And that's why we need to do multiple lake sediments in order to get a clear message. When we see a great big pile of ragweed pollen, we know that this is a cropland weed and that it increased fairly rapidly, and it suggests that this is about when Europeans first arrived in this particular area. I've personally analyzed more than 200 tree ring cores. We look for the spacing in order to see the growth rate, and that gives us a hint about climate or competition. I've crawled into cracks in a petrified sand dune, looking for pack rat middens full of dried seeds and old twigs that can be analyzed. I helped ecologists track plant invasion by noting the phytoliths in hundreds of soils. I've used radiocarbon to estimate the ages of soil layers buried by river floods. This particular example comes from my farm in western Wisconsin. I've crawled into caves to help measure stalactite growth, but I count that only half because I didn't do any of the chemical analysis. And I've watched people analyze gas bubbles in very old ice. In short, I have some experience with the advantages and the technical problems of a number of different ways to observe the climate a long time ago. This gives me a pretty good base for examining evidence about links between climate and history. And in this session, we will look at some presentations from the online Giants curriculum. I'll show the URL later, and the handout packet has a direct link to these websites. So what we're going to look at are a series of presentations that are designed as guides for students doing hands-on activities. And the activity masters will be on the Giants website. So with that as background, let's look at some effects of climate changes in history. So one of these PowerPoints talks about the movable desert maker. To understand the role of climate in history, students should be aware of 3 separate things: the system that makes tropical deserts, the systems that cause natural climate cycles, and the process that could make a desert move. Like we said, a typical climate map has an enormous amount of information. It's almost impossible to remember this image. Let me repeat that. It is neurologically impossible for a student to remember this image. There is no such thing as a visual learner from something that's this complicated. So let's declutter it and focus on just the major deserts of the world. Yes, the Giants website has a master so that teachers can print this map for students to mark as they watch. But first, let's ask a very simple question. What causes a tropical desert? And the answer is rain near the equator. Here's how it works. I've turned the globe so that the equator is up, and sun-heated air rises and makes rain near the equator. And that air has to come down somewhere. Now, it can't come back down right at the equator because the system there is pushing air up most of the time. So given the present facts about the Earth, things like its size, its rotation speed, how far it is from the sun, what the nature of the atmosphere, down turns out to be close to the tropic lines. And where that air comes down, it makes a desert. Except where trade winds and warm ocean water interrupt that downward flow a little bit. In other words, places like Florida or the Philippines, which are at the right latitude to be a desert, but they've got the trade winds. With that as background, we asked the students to describe the geographic pattern of these tropical deserts. The purpose is to get them to translate this visual image into a verbal statement. So, start on the tropic line, about 1,000 miles west of each continent. Spread out to be about 20 degrees of latitude by the time you reach the continent, and stop when you hit some mountains. In other words, in South America, you're going to stop very close to the coast because the high Andes Mountains are just a few dozen miles inland. In Africa, the desert will stretch about halfway across. And in Australia, it goes most of the way across because the mountains are way off on the east coast. And there are no major mountain ranges in North Africa or Arabia, so the desert stretches all the way across the continent. It even reaches out into South Asia until it hits the Himalaya mountains. In addition to these tropical deserts, there are some mid-latitude deserts that are called rain shadows. They occur east of the mountains in the mid-latitudes. There's another one down here in South America called Patagonia. There isn't one in Africa or Australia because the continent doesn't reach far enough south. So that's a climate lesson. How does this relate to history? Remember how the tropical deserts are made. Recent research clearly shows that if the Earth as a whole is warmer, the air is pushed higher above the equator, and it comes down farther away from the equator. This simple graph is based on thousands, probably millions by now, of tree rings, cave records, lake sediments, and other proxy measures of past temperatures. And the website has a master so that teachers could print either a blank graph or an annotated graph for students to mark as they watch. So let's put some key historic events on this graph. The glaciers are melting about 9,000 years ago. Hunters thrive because the Earth as a whole is getting warmer, the population of big animals are getting bigger. And then the climate starts turning down a little bit colder, and agriculture starts. It's kind of backhand evidence for the Boserup hypothesis for those of you that are into great biogeographical controversies. Central Asian nomads were during a relatively warm period called the post-glacial hypsothermal maximum. The Indus Valley did fairly well during another warm period. Turkey was exceptionally rainy during a cold period, and that allowed the Hittites, for example, to move south of the Black Sea. And then the Sea People came during a relatively warm period. Greece was rainy in a cold period. We actually call this time the Roman climatic optimum, and Rome expanded northward into Europe. Climate turned cold. Barbarians invaded Rome. The Han Dynasty was collapses in China because barbarians were invading from the north. Vikings and Mongols, we've got a separate unit about that in a few minutes. The Ming Dynasty collapsed during a very cold time called the Little Ice Age. In other words, there is a relationship here. To make sense out of all these facts, we can put them on a world map of deserts. Remember, the tropical deserts are made where air that rose at the equator is pushed back down. This downward movement will be farther away from the equator if warmer air makes the storm stronger near the equator. Let me repeat that. The subsidence, the downward air movement that causes deserts, is going to be a little farther away from the equator if warmer air makes the storm stronger near the equator. Now, the science that backs this up is not what I would call easily accessible for ordinary citizens. The equations, however, make some very specific predictions. And there's a print activity for students to mark as they watch, or as a review afterwards. So, when the global average temperature is high, the desert maker is pushed a little ways away from the equator. What places are likely to be helped? One place that is dramatically helped is going to be South Asia, and particularly the Indus River Valley and the upper reaches of the Ganges. Another place that's going to be helped is Mesoamerica, the Teotihuacan, or the Maya civilization. A place that would be helped is in northern Peru, the Nazca or Cuzco situation. Theoretically, places in West Africa and in northern South Africa are likely to be helped, but I put a question mark by that one because although the climate got a little bit warmer and therefore people would be likely to have more agriculture, the extra rain would probably also encourage more malaria mosquitoes, and that might have canceled out the good effect, at least some of the time. And the China situation is extraordinarily complicated because while the desert is pushed a little ways away from the equator and the climate is a little bit warmer, it also tended to bring big catastrophic floods. And because the land is so flat, those often wound up killing tens of millions of people. So let's just put a bunch of question marks by that and leave it open for a second. If the climate is warmer, some of these northern areas are likely to get warm enough for farming or for more successful grazing. That'll come back again later. In the meantime, let's take our map and put on what places are likely to be hurt. And the answer is basically all of the places that are just a little farther away from the equator than the big tropical deserts. And, by the way, these areas have all had serious droughts recently. Cape Town has been declared a national disaster. Chile experiences the worst drought on record. Australia's decades-long drought is likely to get worse. California has about 1 year of water left. So yes, the fires that are happening in California are serious. But they're not because the globe is getting warmer in California. It's because the globe is getting warmer near the equator, which makes the tropical desert move a little farther away from the equator, which makes California dry, which makes a chance for a whole lot of fires recently. And located just north of the Great Sahara and Arabian deserts, the Mediterranean region is especially vulnerable. And we saw that with Greece, with Rome, with the Hittites, and today with Syria, where there were about 500,000 climate refugees who had been driven off their farm by the fact that there wasn't enough water to irrigate the fields before ISIS came along. And a recent article in the New York Times, you can find it easily on the internet, has suggested that even the Akkadian and Sumerian civilizations were terminated by an exceptionally dry period. In other words, when the global temperature is high, the desert maker is pushed farther away from the equator, and we can use a map to predict the places that might be hurt or helped. On the other hand, when the global average temperature is low, the desert maker moves a little bit toward the equator. The places that are likely to be helped are all of the ones that we just named as being hurt by when it was pushed away. And the places that are likely to be hurt are places like Mesoamerica, South Asia, North China, and the area around the Songhai and Mali and Ghana empires in West Africa. Plus all the northern areas that still had plenty of rain but got colder and drove the barbarians, the steppe nomads, southward to invade places like Rome or Han China or Ming China. That's the science behind a very simple fact. Climate change had a huge impact on history. Global warming is bad for some places and good for others, and we've got the science to help us predict where and when. Now, if we were in a live workshop, we might ask whether people wanted to have a little bit more prior knowledge. We'll just put these PowerPoints up on the website and give you a real quick summary. One of the PowerPoints talked about natural cycles, and it said, yeah, we've got natural cycles because the Earth's orbit is not a perfect circle. And there's lots of websites, NASA and NOAA and so on. It's fairly complicated, but the bottom line is that solar energy varies a lot. And it seems to have reached a high point roughly once every 100,000 years. Not uncoincidentally, both temperature and carbon dioxide also reach a peak roughly every 100,000 years, synchronized to that solar cycle. We give students a graph activity to help them to discover that indeed there have been 100,000-year cycles, natural cycles of temperature. But a key part of the global climate system has been pushed way out of line with natural cycles within the last couple hundred years. And then a map activity lets them follow a long chain of cause and effect that starts with a stronger storm near the equator, which then makes warmer water, which makes stronger hurricanes, which makes more heat transport, which makes less, and so on, and finally winds up pushing a mass of cold air into Texas. So when the United States has a polar vortex, and it is unusually cold in places like Michigan and Oklahoma, and legislators in both Michigan and Oklahoma are saying, oh, this is just a natural cycle. We should tell them, you really ought to look at the world as a whole. Because although Michigan and Oklahoma were unusually cold in 2014 and again in 2019, the rest of the world was sitting there and saying, can global warming be real if it's unusually cold in Michigan or Oklahoma? And the answer in about 100 languages around the world is yes, 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 and yes. Here's the big point from this PowerPoint. Global climate change is not just about temperature. It's also about deserts. If the global average temperature goes up, the desert maker gets pushed farther away from the equator, and it is possible to predict the places that could be hurt. These are the places where climate change had the most important impact on history. The handout packet includes a bibliography of some of the key studies. I've updated that bibliography a little bit more recently, so the websites that we'll show you later will have more recent versions of this bibliography. Note that these researchers are based in universities all over the world, as well as in the United States. And let me repeat one more time. Just north of the huge Sahara, the Mediterranean region is uniquely vulnerable to a moving desert. Now, this presentation was about deserts. We could also talk about hurricanes, tornadoes, hailstorms, drought, soil moisture, stream flow, blizzards, glacier melt. In other words, there are lots of other consequences of global warming that happen in different places. Those don't tend to be quite as obvious in history. And like all of our PowerPoints, this allows teachers to use them and to actually modify them for their own classrooms. It just says, don't put it up on the website without showing where it came from. So with that, let me show you 3 shorter PowerPoints, one of which puts climate on the geohistogram. That's a graphic organizer that we have on the websites here. And then we'll take a look at the Vikings and the steppe nomads. So, the geohistogram is a graphic organizer that helps students put historic events into their time-space perspective. By overlaying climate information on this geohistogram, we can explore the possible effects of climate cycles on historic events. Like we said, it's a graphic organizer, and we've made an electronic version of it. The website will tell you about that. In fact, there's a whole session about it at this NCSS conference later on, so you might want to go look at that one. On this graphic organizer, time goes from the past on the bottom to the present at the top. By the way, that's how the brain timeline actually is in your brain. You can add as many empires to this as you want. One basic use, of course, is just to point at it and, get the wall version of it. And when you show a video about the Mongols, just point, say the Mongols were about there. Students will automatically incorporate that was in the upper right-hand corner of the diagram, and therefore they're relatively late and they're way off to the east. Another part of their brain is going to say it's between the Song and the Ming dynasties. It's a spatial sequencer for the geeks in the crowd here. And another part of the brain is saying, oh yeah, that's about the same time as the Delhi Sultanates. Now, it helps if you verbally reinforce that by saying something like that when you point at it, to say, the Mongols were just about the same time as the Aztecs. Another use is that students can use a printed activity and overlay information in order to see relationships among topics like climate, empires, and disease. And like I say, there is a student activity page in your handout packet and on the website. Students can use a red highlight marker to mark a warm time, and then go on to mark the cold and warm times through history. This is what it looks like. And now they can take a look at how Rome actually existed basically during the warm climate time. That it won over Carthage because Carthage was being hurt by colder climate, by the moving desert that allowed is not the right word here. The moving desert actually interfered with farm production in North Africa, and Carthage became relatively weaker. And Rome became stronger until the time climate turned colder and the barbarians from the north got hungry and started to move south. Anyway, students can look at that when they've marked this all up. In other words, the geohistogram is a way to organize knowledge. It can be used to explore relationships between climate and historic events. And like I say, there's a whole printed activity and a separate PowerPoint about that. It's very valuable as a way to generate hypotheses for further inquiry. Like, what really is the relationship between climate and Roman history? And how could we go about exploring that? Because at least twice in history, a warm time helped grassland nomads become stronger, and then a cold time forced them to move a little bit further south in order to keep finding food. The warm time helped trade across the hemisphere, and trade tended to help plague spread from east to west, from China toward Europe. This happened, like we know, twice in history, right at the end of a relatively warm time. The first one is called the Byzantine Plague, and it helped break the Roman Empire further apart. The second one was the Black Plague. And there's some evidence that this happened once before, just about at Hittite time, or at about the time that the Hebrews moved out of Egypt into Middle East. In other words, there is some evidence for an earlier wave of trade and disease just in time to get incorporated into stories like the Exodus of the Promised Land. Like I say, this is a big and very complicated topic. In other words, this is a prompt for further inquiry. It's not a presentation that says this is the way things were. And that's a really quick look at climate and history on the geohistogram. You can check the website for more activities. And with that, I'm going to show you one of the PowerPoints about the way in which climate might have influenced history. I'm going to look at a time period when the Vikings became, well, we shouldn't call them the Vikings. They were the Norse. Viking is actually a verb. It means to go out and trade and raid. There are masters for printed activities that can be used to preview or support or review this presentation. The presentation says, about 750 in the Common Era, the Norse people lived on several cold peninsulas and islands in north-central Europe. Now, Europe is unusual. It is a continent made of peninsulas. And there's a definition card on the PowerPoints to make sure that the students all know what we mean by peninsulas, because European history is really guided by the fact that people could hide on a peninsula and become relatively strong and then still be relatively safe. And there's a Greek peninsula, an Italian, an Iberian, a Scandinavian, Jutland. In other words, lots of peninsulas that were important in European history. So what made the people who lived on these peninsulas such a big part of history at a particular time? And we suggest that, like any interesting story, it's kind of complicated. Part of the Viking story is the effect of inventions, and a transportation invention helped them to rise. A construction invention led to their demise. But another part of the story is the effect of climate change. Now, you remember this big complicated graph here. Starting about the year 800, the Earth became warmer, in fact, almost 1.5 degrees warmer. Here is a detailed record of temperatures in Denmark, because there are a number of lakes and caves and other things in Europe that people have looked at to find these climate proxies. And what they say is that the average frost-free season in the year 800 was about 105 days. By the year 1000, the frost-free season had expanded to nearly 170 days. Now, why is this important? Is because corn and other grains need about 120 days. Central Michigan has 140 days right now. In other words, Denmark turned from being like Northern Ohio or Indiana to being like the Upper Peninsula of Michigan, and then back. A chance of crop failure in the year 800, about 1 out of 3 years, it would be get an early frost. By the year 1000, it was 1 out of 20 years. In other words, the Norse homeland became dramatically more productive. People didn't die of starvation at age 3. They grew to maturity. The population increased, and the Vikings spread out. By 850, they had spread out, maybe 500 miles in every direction. And that spread was aided by an important invention, the longship. This ship is designed to float in just 2 feet of water and still survive in the ocean. The longship could travel on shallow rivers and lakes as well as deep oceans. And with this ship, the Norse, and I put it in quote, visited a lot of river towns all over Europe. They came as traders, and if you didn't want to trade, they could make you a deal that you couldn't refuse. And the result was the Vikings had a tremendous impact on European history. By the year 1050, they had gone as far as Spain, Rome, Moscow, Constantinople, Afghanistan, even North America. By that time, however, the people of Europe had begun to learn how to resist more effectively. And one particularly useful invention was a castle where you could store maybe 200 troops and enough food for 3 months. In other words, just build your city walls and castles so that they can resist attacks for months. At the same time, however, the climate started getting dramatically colder. It's the beginning of a period of time that is now known as the Little Ice Age. Later, it's going to have an effect on the Ming Dynasty. In summary, this is a simple story. The rise of the Vikings is a warming climate and the invention of the longship gave them a tremendous advantage over settled people. A cooling climate and the invention of castles greatly reduced that advantage. Here are some of the websites and books that you can go look at in order to find out a little bit more about the ships, about the castles, about the Viking world. And like I say, our copyright notice gives teachers the right to take that presentation and to modify it in any way they want for their own classes. So that's one fairly simple story. Let me poke my nose into a more complicated story for you about the steppe nomads and the Indo-European languages, and then we'll go look at some handouts. So I'm going to race across a PowerPoint. I'm going to even skip some parts of it. That is up on the website for the Giants and up on our clickable maps eventually. This photo shows what the vast steppes of Central Asia look like. Steppe is the Asian word for grassland. The grasslands stretch all the way from Europe to China. We're going to focus at first on a small area north of the Black Sea and the Caspian Sea. The climate in this area is cold and dry, just like central Canada, which is at the same latitude and is also a grassland. Now, you could ask, why would we look at the grasslands in the middle of Eurasia? And the answer is because your language, if you're listening to me and what I'm saying, and a lot of important inventions came from this part of the world. So about 7,000 years ago, some people lived in forested valleys near the edge of this grassland, in places like that. These people lived in wooden houses. They ate seeds, fish, fruit, and meat from horses. They were the easiest to hunt animal at the time. For 1,000 years, their population grew. Hunting became harder as they killed off the big, slow animals, including at least 3 of the 5 species of horses that were there at the time. The people learned how to keep horses for milk and meat when hunting was not successful. The population kept growing. Hunting and herding became harder as the grass near their villages was overgrazed. Necessity is the mother of invention, and these people invented things like bridles and saddles, other things that would allow them to ride horses. This allowed them to go much farther away from the river valleys. All of this land became available for horse herding, and they began to sell horses to people in other regions, as near as the Danube Valley in Europe and as far away as China and Mesopotamia. In other words, there was a pre-Silk Road long before the Silk Road that involved horse trading between the steppe people of the Caspian and China. And then the climate turned colder. Some of these people moved away. They moved south of the Black Sea. They became known as the Hittites. We'll see them a little later in the story. And now I'm going to skip 45 frames of the PowerPoint. In a few thousand years, the 45 frames had stories about wagons and chariots and kurgans and more climate changes. And I'm going to go straight to a summary. Some of the people, when times were good, moved northwest. They became German, Dutch, Danish, Swedish, Norwegian. Some of them went west. They became Celts, Picts, Scots, Irish, Welsh, Romans, Italians, French, Spanish, Romanians. Some went north. They became Ukrainian, Russian, Polish, Belarusian. Later on, some of them went southwest. They became Greek, Serbian. Some of them went southeast. They became Persian, Indic, Bengali, Hindi. As these people moved, they took their language with them. How do we know this? Because several thousand words stayed the same. In ancient European, for example, wheel is a rote, and axle is axe. And this is what those words look like. In Baltic, it's rati and asis. In Old Russian, roughly the same. In Old Indic, ratha and axis. In Old Persian, ratha and axis. In Old Greek, rotha and axo. In English, we say wheel, which is a different word from a different place, but we still say axle. We also say round and rotate and rotary and radius and radial tire and axis and axial. In other words, a lot of modern languages started as one old language spoken by some horse herders and horse traders in the steppes of Central Asia. And those people moved north when the climate got warm and south when the climate got cold. And they basically wound up all the way from Wales and Britannia to India. There's more archaeological information. The story has been verified by DNA evidence, and we give you references to that. In other words, this is one more example of a PowerPoint that's out there. Now, I will make a separate run at the PowerPoint for the fall of the mighty Ming. But for those of you for whom time is short, I'm going to jump over and take a look at the handouts. And then I'll do the Ming story if we've still got time near the end of this session here. In your handout packet, you're going to have about 20 things. One of them will be the movable desert activity. You can do this all by itself, or you can link it to the climate change activity. And on the websites that we'll give you at the end of this handout packet, we've got a clickable version of this climate map. If you really want to get geeky, our handout packet includes some of the stuff about the various orbital dynamics and that carbon dioxide activity that I showed you earlier. If you want a simpler version of it, there's a handout about the relationship of climate and latitude, and this is linked to another website about Earth environments that I'll show you later. And there's an activity where students actually construct that, and they put clouds on the rainy belt near the equator and lines on the desert near the tropic lines. There's an activity that shows how the equatorial rainy belt moves through the seasons in Africa. And there's an activity that links that because about 30 states have got a standard about reading climatic graphs. We've got a separate activity about the Desert Maker and an activity about the major deserts of the world. These two activities come from a book called Teaching Geography. There's a handout about the world geohistogram and a page of background that recaps what I said in the PowerPoint, and then the activity about climate on the geohistogram, along with an example of what it looks like when you've got it all done. You could just clip this out and put it in your PowerPoint if you want. I do have an activity about trading germs, a disease on the geohistogram. There's an activity about peninsulas in European history and the Northland activity that I showed you earlier. There's a background timeline about the Indo-European languages, and there's 3 different versions of a map activity that students could do. One that is a standalone version, and then a simple and a complicated version that matches what you saw in the PowerPoint. And a teacher's guide that shows you how you might use that. There's also a worldwide version of the words in different languages, and a little short activity that I didn't show you about the spread of the war chariots, because the people from north of the Caspian actually wound up selling chariots to people in Egypt, Mesopotamia, and China. And then finally, there are the websites. And I will leave this up a little longer for people who didn't download the activity packet. But I mentioned the curriculum called Giants, and that website is very simple. SS for Social Studies at the Ottawa Area Independent School District .org. Then there's a clickable maps package, and that's a little bit longer website, textbooks.wmisd.org. And then after the slash, Geographic Big Ideas, all one word. And then finally, if you want more about the neuroscience that backs this up, there's a website called Our Spatial Brains. And in very fine print here, I've got the URL for a longer website, also at the WMISD URL called Earth Environments. This one is still under construction, so you might want to check that every few months to see what changes have been made. So the last button on my one here talks about the fall of the mighty Ming. I wouldn't show this in Michigan because, in fact, this particular one happens to be outside of the time frame for our 7th grade world history class. But we've got a number of Michigan teachers that use it in a high school class. So this is another story where climate change turns out to be a big part of the story. It starts out by asking the students, because this is going to be a high school class, what has China been doing that makes some Americans worry? Have they stolen our jobs, for example? Are they testing nuclear weapons? Are they the #1 exporter? Is that a problem? Are they threatening other ships in the South China Sea? Do they have a research satellite up in orbit? If they built 3 times as many, you get the idea. They're building 10 times as many solar collectors. They built a 4-lane highway system as big as our interstate system, and they did it in 6 years. It took us 45 years to do it. They're building hospitals, power stations, ports, railroads in many other countries around the world. What are they doing that are making some people worry? And that's kind of a context for what's going on over there. And I suggest that some of China's success might be influenced by what happened 500 years ago during the Ming Dynasty. That gives us another reason to look at Ming China. So on the geohistogram, the Ming Dynasty is off on the east end of the diagram, and it's about 1500, which means it's after the Mongols. It's roughly the same time as the Habsburgs, the Reformation, the Songhai Empire in West Africa. The Ming are known for spectacular architecture, for just truly great ceramics, metalwork, complex, intricate fabrics, furniture. This particular picture came out of an antique seller's website where they were asking $10,000 for this table. And some huge ships. These 2 ships existed at roughly the same time. This is Columbus's ship, Santa Maria, going across the ocean. And this is Admiral Zheng He's flagship as he's traveling around the Indian Ocean at the same time. And for the people in New York who don't think anything exists west of the Hudson, this is the Staten Island Ferry at the same scale. The trading networks the Chinese had went from China to Africa, Southern Europe. Behind the Great Wall, which they rebuilt, the Ming had a 1-million-man army. That army had rockets, it had gunpowder, it had cannons, it had very well-trained troops. In fact, this looks exactly like, George Washington training troops at Valley Forge and how to have a musket work. So here comes a really puzzling question. How could a country that was this rich, this sophisticated, with art, silk, pottery, this powerful 1-million-man army armed with rockets, how could it ever fall to a small band of nomads from the north? I mean, it would be like Guatemala defeating the United States. I picked Guatemala because it's roughly the same proportion of population and wealth as the Manchus north of the Ming Dynasty and the Ming Dynasty. Now, here's a problem in my mind. If you go out to Wikipedia and figure out why the Ming fall, the first 20 links talk only about corrupt government, rebellion, police brutality, riots. In other words, they're saying that the Ming Dynasty fell from within. We give the students a reading that might raise a question about whether that's the whole story. Now, the handout packet also includes a student briefing, which is a background of what I've just shown as a PowerPoint. So you could just give that as a student briefing if you don't have the time for the PowerPoint. And we've got a simple graph that shows temperature. It shows when agriculture started, when irrigation was needed, when South Asia did well, when Rome expanded into Europe, when the barbarians invaded both Rome and China, when the Vikings were important in Europe and the Mongols were important in Asia, and when the Ming Dynasty fell during one of the coldest periods of time in 6,000 years of history. This handout tells about the fall, and it is made for middle school. The first sentence, in case you can't read it, is, "This is a story about how some soldiers ended a battle by eating all the dead soldiers." It's a true story. It really happened. And we can learn something about it, not about eating people, about what happened when the climate changes. So that there's a story made for middle school. And then there are some questions. And there's two versions of these questions. And the questions ask students to circle an F if you think this sentence taken from the story is about fact, or if it's about a theory, or if it's about an opinion. Because the whole lesson is really an ELA lesson about discriminating different kinds of sentences, facts, theories, and opinions. Then there's a page about fake news. That probably is a pretty important topic for students to be talking about these days too. And they can do a cause and effect diagram where they link the cold climate phase with drought, which in turn allows locusts, which leads to crop failure, which leads to famine. In other words, we're setting up a climatic reason for a series of problems. Some people also know that the Ming Dynasty was a time when Confucius became a little bit more popular, and one of his major analects was about when in a state of security, a superior person does not forget about the possibility of ruin. When all is orderly, he does not forget that disorderly may come. So let me go all the way back to the start. What lesson might be relevant today? China's population history shows at least 4 times when a major dynasty ended with a dramatic loss of population. Half of the people died out for one reason or another around the fall of the Ming Dynasty. And I can assure you that the invading nomads did not kill half of 100 million people. What happened was a climate change that led to floods, it led to frost, and then that was exacerbated by 2 of the biggest volcanic eruptions in history, which in turn lowered global temperatures, and the result was massive famines. And the famines led to people blaming government, rioting, rebellion, insurrection, and that led to crushing the insurrection and police brutality. And here's a historic fact for you. The Ming emperors actually invited the Manchu. They opened the gates of the Great Wall and invited the Manchu army to come in to help them put down the rebellion. And after the Manchus had finished off putting down the rebellion, they went ahead to put down the Ming Dynasty. You're going to hear this time and time again. Climate change in history has been bad for some countries and good for others. And a culture that learns to save is going to be well positioned in times of change. Right now, China people save on average 46% of their income for investment in things like roads, ports, ships, factories. The US, by contrast, saves and invests only about 17% of our income these days. I'm just suggesting that might have something to do with some of the headlines that we see these days. What are some consequences of a difference in savings rate? And with that, the short version of the Ming Dynasty story, one more example of some effects of climate change in history. Those are the big PowerPoints, the websites. One more time, just in case you want to go out and look at them. And you can download virtually everything that I've showed you from those websites or from the NCSS packet. Thank you all very much.